David, are you here? Yes, somewhere you're here. Are we ready to begin your slideshow, David? All right. David has an interest in cosmology and we're going to give him the microphone. He's put together a slideshow.
Suck it up the tile. What? Suck it up the tile. Yeah, suck it. Oh, suck it.
Okay. David, you're gonna show slides and tell us about them, right?
Practice with the microphone, right? Okay. All right. How are we doing for light? Okay. Thank you, Trinity, for helping.
This is an introduction to black holes. I've been reading about black holes for a long time, and I'd like to share some of what I've learned with you. I think that black holes are interesting because there's one in the center of our own galaxy. I have a theory based on the rubbery sheet theory about them. I'll tell you more about that later. They could be related to wormholes and time travel. They leak radiation over time and eventually disappear. Physicists argue about what happens in singularity. Everything we know about the way things work could be completely wrong in a black hole because there is no time in singularity. Slide.
Would that be good if it was a little louder? Yeah. Okay. Good stuff.
Slide.
Space ball.
Do you want to go help him?
Yeah. Well, want to here? The space bar, Paul? Oh.
Do you want to do it first?
Sure. There we go.
Black holes need stars. Black holes form when a star explodes. This is called a supernova. Slide. Black holes are dead stars, but not all dead stars are black holes. Neutron stars are dead stars too. After the supernova, there is not enough matter in them to collapse into a black hole. They're small, about 15 miles across usually. Neutron stars have a solid crust but liquid core. They have a large gravitational pull like white dwarfs. But neutron stars can become black holes, unlike white dwarfs, if they pull enough matter into themselves. White dwarfs are also dead stars. They're smaller than neutron stars. When they cool off, they will become black dwarfs. Our sun will become a white dwarf. Slide. That's a neutron star. That is a neutron star. Neutron stars, small, crusted core, can become black holes. That is a white dwarf. White dwarfs become black dwarfs. Our sun will become a white dwarf. Slide. Light does not escape from a black hole. We cannot see black holes, but we can locate them with special satellites by finding areas of space that no light escapes and are definitely not new moons. You know, when the dark side of the moon is facing Earth. the possible black holes in this satellite picture of deep space? Nadia. Oh, you mean this? You mean here? Here? Good eyes, Nadia.
Is that right?
It's okay, Paul. You can do a slide.
Are we ready for the next slide?
Yes. Slide.
Because she was raising her hand. Do I previous slide for this? Slide? Boop, boop, boop. You mean right there? Here? 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 At the top of the slide? Here? This? Here? Here?
Okay, David, let's move on.
Okay. These circles locate some of the possible black holes in this satellite in the black hole area of space. We missed some of the possible black holes. Slide. Here is an illustration from NASA light being destroyed as it enters the black hole. There's the light being sucked in. Slide. Here is an image from the Hubble Space Telescope of a star being torn apart and sucked up by a black hole. There's the original star. That white arrow shows its path. There it is being stretched, torn apart. There it is being sucked in, and there's the black hole. Slide. The parts of the black hole are the singularity, or black hole center. The accretion is a gigantic swirling disk of gas and dust that swirls around the singularity, and that the singularity feeds on. The energy jet releases energy from the black hole. Anything that passes the event horizon cannot escape the black hole. The event horizon is an area right in front of the black hole. If it passes and hits the singularity, it's gone forever. There's the energy jet and one right there. Two ones. Ready? Now, slide. Chandra satellite images. These images, except the illustrations, were from the Chandra X-ray Observatory. It is the largest telescope ever launched by the space shuttle. 45 feet long, and its orbit is the highest, about a third of the way to the moon. Slide. Mover to shaker. Chandra was launched on the first space shuttle mission commanded by a woman, Commander Eileen Collins. Slide. Questions, anyone?
David, can I choose a couple people for questions?
Yeah.
Okay. Is that Ian right there? Yeah, Ian.
Well, there's a theory about that, but I don't want to actually tell you.
It's okay. Actually, David has a slide about that. If it's okay, Paul, can you go to the next slide?
Slide? Rubbery sheet theory. See, Einstein came up with this. Albert Einstein. Yes? The person who everybody thought was the smartest man in the world. A planet is a planet. So he thinks here space is accepted as a rubbery sheet, as in his theory, where objects sink into holes are wells of gravity. Planets, Earth, for example, are less massive than stars. The sun is the example. So they are less massive than stars, so they do not sink in as deeply. And he thought black holes are a bottomless hole in space. There's the black hole. If this is true, I think the black holes are cut in the rubbery sheet theory, while there is a curve in it and the dark edge forms a wormhole leading to another cut. So if we could encounter rotating ones, then we would be able to bounce the gravity, and we could even probably use it as a wormhole, which is of course linked to my theory.
Hey, David. We're so far out of time, I don't think there's time for any more questions, but I have an idea. You tell me if this will work for you. If they have questions that they really, really, really would like you to answer, they could write them down on a piece of paper and deliver them to, out to the office, and we'll ask Wendy tomorrow there to collect them, and then she can give them to you. And you can either write them answers, or you might be invited to their classroom to answer some questions. How's that?
Sure.
Nice job.